We're going to use the Python programming language in this course as it's pretty easy to learn and use, and it's widely used in the world of data science and machine learning. In the real world, you'll get much better performance using languages like Java or C++, but I didn't want to shut out students who aren't comfortable with lower level languages like that. Anyhow, if you already know Python, you can totally skip this section. But if you're new to Python or you need a refresher, I've got a very quick crash course for you here. You are going to need some experience in programming or scripting for this to make sense. I mean, I can't teach you to program from scratch in just one section of a course. So if you've never programmed anything before, it would be a good idea to go grab a deeper introductory course on Python and go through that first before coming back to this course. Otherwise, let's shoulder on and learn the basics of Python. For our intro to Python, we're going to use a format called a notebook. This allows us to intersperse code with nicely formatted text that explains what's going on and lets us run our code in one little chunk at a time. So the first thing we need to do is install a component into Anaconda called Jupyter Notebook. To do that, just open up Anaconda Navigator. Click on Environments, and select our RecSys environment. Now click on Home, and under Jupyter Notebook, hit Install. Once it's done, hit Launch, and it should bring up a page in your web browser. Now hit the Upload button, and navigate to the Getting Started folder inside your course materials. In there, select the python101.ipynb file. It should now appear at the top of your file list. Hit the Upload button next to it, and once it's uploaded, find it in the file list and select it to open it. If you've never seen a Jupyter Notebook before, the way it works is you can click in any of these boxes of code and hit the Run button or Shift-Enter, and it will execute that code right from your web browser. Let's try it with this first block. Click inside of it to select it, and hit Shift-Enter. Now we're just going to cover the syntax of Python here and the main ways in which it differs from other languages. So let's take a closer look at this code. One thing with Python is that white space is really important. Any nesting of code, like for iteration or conditional expressions, relies on the number of tabs to group code together, instead of curly brackets like other languages. So here we have a list of numbers. In Python, a list is like an array or a vector in other languages. We define a list of the numbers 1 through 6 by putting them in between square brackets separated by commas. In Python, there is no character required to terminate a line. You just hit Enter when you're done. Let's add 7 to the list, just to prove that running this actually does something. Yeah, we've got results for 1 through 7 now. Next, we have an example of a for loop in Python. This statement iterates through the list named list of numbers, storing the current iteration in the variable number each time. A for statement does have to end with a colon like this. But now we use indents to indicate what code lives within this for block. And here we have an example of an if-else clause. If the number is evenly divisible by 2, we print that it's even. Otherwise, we print that it's odd. And again, we use indents to indicate what code lives within each if or else clause here. We'll remove all indents to get out of the for loop and print all done at the end. Notice that we never had to declare any variable ahead of time, nor do we have to define their types. Python is what's called a dynamically typed language. It tries to infer the data type of your variables based on how you initially use them, but internally they do have types. You can also explicitly cast variables to different types if you need to, but variables won't be recast automatically as they would in weakly typed languages. Sometimes this can lead to unexpected errors, and we'll see some of that as we go through the course. Let's move on to the next block, which just shows how to import external modules into your Python scripts. You just use the import command for this, and you can define an alias for the module if you'd like to save yourself some typing too. So here we're importing the NumPy module, so we can refer to it within our script, and we're importing it under the name np. This lets us then use NumPy's random function by just typing np.random, and in this case, we're asking NumPy to give us 10 normally distributed random values with a given mean and standard deviation.